Welcome back, Calculus. We are continuing implicit differentiation, and I'm going to move on to the next ones, which actually involve more rules. So as you look at this first one, I would quickly identify that this has the product rule in it. So make sure that you remember your product rule, chain rule, quotient rule, all of the above as we learn new things. So remember the product rule, you take the derivative of the first piece, so the derivative of 2x would just be 2, then you leave y alone, plus you leave the 2x alone, and then the derivative of y, don't forget, is dy dx. And then on the right side, you get 6y dy dx plus 2. Now this would be a problem where I think it would be smart, it would be advantageous, especially if you have to simplify this, because all of these numbers are divisible by 2. So I'm going to do that and another step at the same time. So I have this x dy dx, again because I'm dividing by 2, minus 3y dy dx is equal to 1 minus y, because I'm going to subtract y to the right side. And remember, it's 1y now after dividing by 2. And the whole reason to do that is to factor out a dy dx. And remember, in the first video, I told you that eventually we'll get to a point where you probably won't have to show all of those steps. Now, if you have a problem that says prove or show why the answer is what it is, then you do need to show every little step. So it is beneficial to practice it. And hopefully that made sense, even though I kind of stopped explaining and I just kept working. Okay, so then let's move over to the next one. Again, if you feel like you need to pause and really grasp what's going on, then please do so. Because as I look at the next one, I'm looking at the 15x squared. Don't forget the derivative of a constant is 0. You don't have to write plus 0 down. Is equal to 2 dy dx. We have another product rule. So the derivative of negative 3x squared would be negative 6x. Leave y alone. Now, I know the product rule is plus, but you have to distribute that negative to each one. So minus 3x squared, and the derivative of y is dy dx. Now, as I'm looking at this, there's no common factor between anything. So all I could do is add 3x, nope, I'm going to add 6xy to the left side. So 15x squared plus 6xy will be equal to, let's go ahead and factor out that dy dx in there as well, 2 minus 3x squared, and then it's sort of like a multiplication problem that you can solve it by dividing over. So we have 15x squared plus 6xy all over 2 minus 3x squared. And this derivative will find us any slope at any point on this it's not a function anymore, of this curve. Yeah, so again, pause the video, make sure you understand every little step, and come to class with questions if you have them. So as I move on to the next one, for what values of x will this curve have a horizontal tangent? We've seen this question before, it's just now we're doing it implicitly. Well, let's take the derivative. 3x squared plus 3y squared. Don't forget that chain rule, dy dx. Now we have a product in here, so that would be the derivative of 4x, leave y alone, plus leave 4x alone, times the derivative of y. And don't forget the derivative of 1 is 0. You don't have to write it down. So what do we have next? Again, I'm going to do 2 steps at once. So I gave you a hint, like at the beginning of the first video, that at some point I will anticipate you guys doing this without so many steps. Then I'm going to factor out a 3y squared, and I also needed to subtract this 4x dy dx to the left side is equal to 4y minus 3x squared. So then dy dx will equal 4y minus 3x squared all over 3y squared minus 4x. Now this is where the real work happens. So we need to have a horizontal tangent. Well, that only happens if the derivative equals 0. And that needs to be where the numerator equals 0, because if the denominator equals 0, it's going to be a vertical tangent or something else. It won't be horizontal. You only need to do the numerator. So we're looking at where 4y, as I add 3x squared to the right side, and 0 plus anything is that thing. But that doesn't tell me the value of x. I guess if anything, I could solve for y, right? It would be 3x squared over 4. And then, so this is the location of where it happens. But what's the actual ordered pair is now we have to take these values back into the original function and replace y in all of these. So if you thought calculus was getting more difficult, you're probably right. But these are all the tricks that you've learned probably since dating back to when you first learned equations and things like that. 4x, replace that y with 3x squared over 4 plus 1. Now this is going to be too difficult to do by hand. So what I would do is go to a calculator at this point. So just pull up a calculator. Again, if you feel the need to pause the video and try things on your own, then by all means do it. Plus, I'm just going to put it in parentheses so I don't mess it up. As a fraction, 3x, I already forgot what it was, squared over 4, and that quantity was cubed. And then we also have this 4x times that same fraction, 3x squared over 4. I just want to double check that I typed everything correctly there. There we go. And what I'm looking for is where these graphs cross each other. Now, if any of you are sitting there and saying, well, I could have typed that into a graphing, like Desmos would do this problem, and you can see where you get a horizontal tangent like a relative min or max. But graphing calculators do not. That's probably why they allow graphing calculators on the AP exam, but not Desmos, which could change if the pandemic is still happening. But anyway, I'm just going to hit zoom 6 to go to my standard window, and I want to see where those two curves cross. They definitely cross point of intersections number 5 over here, and I think they're going to cross one more time. So negative 0.770. Sorry, my marker tends to stick to the page. But I also think there's one more point of intersection if I zoom out. I think they intersect somewhere over here as well. So second, trace my point of intersection. About 1.732. So as you notice that work, though, this would probably be something that needs to be on a graphing calculator exam. Because if you get to this is a very complicated equation, like this is x to the third, this is x to the sixth, this is b x to the third again. I don't know if it's even factorable, and I don't want to go down that rabbit hole. So what I like about this problem is then in the very next part, we're going to assume for right now, they're only going to ask you for a vertical tangent if the denominator, notice it's the same problem. So it's setting the denominator equal to 0. So again, probably makes sense to add 4x to the right side. And then it says describe the values of x 3y squared divided by 4, where you would get the vertical tangent. So this, and then you would have to plug into this equation again one more time. And so because it's sort of an open-ended question, you know, of describing in terms of why I describe the values, I would probably just leave it like this. And if they want a description, this is a very poorly worded question. If they wanted a description, you could say, well, it's values of x that are satisfied by this equation and this equation. And it might even want you to explain that you set the denominator equal to 0. But usually, if you show this work, you'll get full credit on at least that point. You don't actually have to describe that. I really want to get to these second derivative problems because it's just the derivative of the derivative, but something really cool tends to happen. So 2y dy dx plus 2 dy dx is equal to 2. Remember, the derivative of 2x is 2. You don't have to write dx because that cancels out. Now, if I were doing this problem, I would divide everything by 2 and factor out a dy dx. So dy dx is equal to 1 over y plus 1. Well, we learned already that the derivative of the derivative is the second derivative. And now what we have is the quotient rule. Well, the derivative of the top is 0. Leave the bottom alone. Well, that's kind of a silly thing to say, but it is what it is. Minus the derivative of the bottom, which is dy dx. Leave the top alone. All over the denominator squared. Alright, well, let's simplify that. Because we know 0 times anything is 0, and we know dy dx is equal to that. So what we're looking at then is that that is equal to the negative of 1 over y plus 1 divided by y plus 1 squared. Well, if you think about dividing by a fraction, that's the same thing as multiplying by the reciprocal, so negative 1 over y plus 1 times 1 over y plus 1 squared. So this final answer, I know I've gone way over here, is negative 1 over y plus 1 cubed. That's your answer to this problem, the second derivative. So again, please pause the video and make sure you really understand everything, because you could be tasked with finding the second derivative of something. And I'm going to start the next one. I'm sure the bell's going to ring again. So 2x plus 2y dy dx is equal to 0. And we've actually done a problem like this before. Dy dx. You subtract 2x over and divide by 2y. Well, those 2's will cancel. So then the second derivative, well, the derivative of the top is negative 1. Leave the y alone. Minus the derivative of the bottom, and leave the top alone. I'm just going to rewrite that as plus. All over the denominator squared. But remember, dy dx is equal to this. So that's equal to negative y plus negative x over y times x. So I'm going to write that squared. And then remember, I'm skipping a step here because I kind of showed you the steps on the previous problem, that dividing by y squared is the same thing as multiplied by 1 over y squared. So if I distribute that in, my answer will be negative 1 over y, because that one of the y's will cancel, and then minus x squared over y cubed. And this is a good enough answer. You might see a different answer on the answer key. Let me just pull up the answer key, actually. Because some of you might prefer this guy's work opposed to my work, and I'm not offended by that. Just sometimes people understand differently. But notice that you do get the same answer. And notice he also changed it. Instead of doing the quotient rule like I did, he changed it to be the product rule, which does work. So I'm going to leave it at that, and you should be ready for the homework now.